What if you could see something without actually seeing it? Imagine you're standing and looking up at the sky. Clouds obscure everything. You can't see a single airplane. But on the screen in front of you, bright dots are moving with incredible precision. You know the exact location of each airplane. How? That's the power of radar. Radar is one of those invisible technologies that quietly keeps the world running. Planes don't crash into each other because of it. Ships navigate safely through storms because of it. Even scientists use it to see underground. But how does radar actually work? Let's break it down, step by step, in the simplest way possible. At its core, radar does something very simple. It sends out radio waves and listens for echoes. Think of it like shouting in a canyon. You yell, and a moment later, you hear your voice bounce back. Let's start with primary radar. Imagine a large antenna rotating, continuously turning 360 degrees. As it spins, it sends out short bursts, called pulses, of radio waves in all directions. These waves travel incredibly fast, straight through the air. Now here's the key part. When those waves hit something big, like an airplane made of metal, they bounce back. Some of that energy returns to the antenna. So now the radar knows two things. Direction, because it knows where the antenna was pointing. Distance, because it measures how long the signal took to return. The longer the delay, the farther away the object is. It's like timing an echo. Fast return means close. Slow return means far. And just like that, radar can detect an aircraft, even if you can't see it. But there's a problem. Primary radar can tell where something is, but not what it is. Is it a passenger plane? A military jet? Something else? That's where the next system comes in. This is called secondary radar, and it's smarter. Instead of just waiting for a reflection, it actually talks to the aircraft. Here's how it works. The radar sends out a coded signal. When that signal reaches an aircraft, it triggers a device on board called a transponder. The transponder immediately sends a reply back. But this reply isn't just a bounce, it's data. It can include the aircraft's identity, its altitude, even additional flight information. So instead of just seeing a dot, air traffic controllers now see a labeled aircraft with real-time details. Next, inside the control tower, computers process signals from both systems. All of that data is combined and displayed on a screen, where aircraft appear as moving points or lines. To the controller, it's like watching a live map of the sky. But not every aircraft wants to be seen. In military aviation, some planes are actually designed to avoid radar detection. These are called stealth aircraft. A famous example is the Lockheed F-117 Nighthawk. Unlike normal aircraft, its shape is carefully designed so that radio waves don't bounce straight back to the radar. Instead, the waves are reflected away in different directions. That means the radar receives much weaker signals, or sometimes almost nothing at all. But shape is only part of the trick. The aircraft is also covered with special radar-absorbing materials. These materials reduce reflections even more, making the plane much harder to detect. This combination of smart design and special materials is called stealth technology. It doesn't make the aircraft invisible, but it makes it much harder for enemy radar to find. And radar isn't just for the sky. There's a special type called ground-penetrating radar, or GPR. Instead of scanning the air, it sends radio waves into the ground. When those waves hit buried objects, or even changes in soil, they bounce back. Thanks for watching. Like, share, and hit that subscribe button for more science stories. And let me know in the comments what you want me to explain next.